With the previous IIPMT question, the problem is like this. A force on a rocket moving with a velocity 300 meter per second is 210 Newton. What's the rate of consumption of the fuel is, right? So let's try to understand what is given for you. He said something like a rocket is moving up with a velocity 300 meter per second. For that, it need to experience a force. What is the force that's developed on that is 210 Newton. For that to happen, it has to eject some gases. He is now asking what is the rate of consumption of the fuel. That means how much of mass of fuel is burned per second. That's the question that he is asking, right? We can solve this basing on Newton second law. What is the Newton second law is? We blindly say Newton second law means F equal to ma. That's not actually perfectly correct. According to Newton's second law, the force acting on a body is equal to rate of change of momentum dp by dt. d by dt of momentum equal to mv. In all the general cases, mass is constant, therefore you write mass outside. It becomes dv by dt, therefore dv by dt is acceleration, then F equal to ma becomes correct. So F equal to ma is correct when mass is constant. But in this case, mass of the rocket is not constant. Fuel is filled such that some fuel comes out as an action. As a reaction, rocket moves upward. So here, rocket moves up with a constant velocity. That means velocity is constant. That doesn't vary with respect to time. So you shall write velocity outside the differentiation. Then it becomes dm by dt. Thus, when a rocket moving up with a constant velocity, force becomes F is not ma, but F becomes V into dm by dt. Once if you know that, solving the problem is definitely very easy. F equal to V into dm by dt. It is given that force is 210 Newton, velocity is 300, dm by dt is how much? That implies dm by dt is 210 by 300, that is 21 by 30, 3 tens and 3 sevens, that is 7 by 10, that is 0.7 kilograms per second. That means this rocket burns this much of the mass, 0.7 kilograms per second, so that it's able to move up with a velocity 300 meter per second. Usually this rocket has to move with much more higher velocity so that they will burn much more mass per second. That's how we have to solve the problem. In the journey, you learned what's the definition of Newton's second law of motion. Thus, this question is very basic and conceptual. We shall have a conceptual clarity to solve this kind of problems. Thank you for watching.